go through 25? It's sketching
Yes.
graphs.
Good. Where are we? Yeah, there we go. So y equals to log 3x, right? What would that look like as a so this is in log form, yeah? What would that look like in index form?
Would that be 3 to the x?
Yes.
Is that what? Yeah.
But that's not a graph yet, or that's not a function yet.
Or y equals 3 to the x?
Yes. Thank you for clarifying that. So y equals to 3 to the x. Yep. Okay. Now, how would we graph that? Well, it's probably easier. Oh, sorry. Hang on.
I was thinking it's 3 to the y equals x.
Yeah, hold on.
Oh, yeah, that makes sense.
So, y equals to log 3 to the x becomes x equals to 3 to the y, isn't it? Okay? Yep. So, how would we graph that? It's probably easier to graph its inverse function. What would be the inverse function to that?
Y is, 3 to the x.
Y is equal to 3 to the x. Now, how would we graph y equals to 3 to the x? What sort of a graph would that be?
Exponential.
Yeah, it'd be exponential graph. What do exponential graphs look like?
They close axes on the left and then
Yeah, sorry, Cameron. Might have to say that again.
okay. Close to the x-axis on the left, and then they go up on the right.
Yep, and it passes through a y-intercept of?
3.
Not quite.
It's 1 usually, isn't it?
Yeah, 1. Okay. So when the y-intercept is when x equals to 0. 3 to the 0 is 1. Got it? So the graph will look like that, right? But when x equals to 1, y equals to 3. Okay? So that's the point 1, 3. Yeah? So that this graph here. How would you graph this graph here from this graph here?
Switch it and make the y the x-axis and x the y-axis.
Yeah, how would you do that? Graph. What would that look like?
It would be rotated 90 degrees.
No.
It would be mirrored, wouldn't it? Mirrored then rotated?
No.
It'd be mirrored about the y-axis, yes?
No.
Oh, okay. I mean, there's only one other option.
So what's that?
Mirrored across the x-axis?
No.
Oh.
Sorry,
hang on. I got it.
Yes, you do.
Yeah, mirrored across y equals x.
Ah, there we go.
Yep.
There we go. So that's the line. Y equals to x. Yep. And it would be mirrored across that. So see how this approaches the x-axis, right? As x becomes increasingly negative. Well, this graph, when mirrored, okay, well, reflected is the right term, will be approach the y-axis as y becomes increasingly negative. Yep.
Yeah.
Just veer off into infinity for x, whereas this graph will veer off into infinity for y. That point there is the point 1, 3. What would this point be if it's a reflection of that point?
3, 1.
Yes, 3, 1. Got it?
Yeah.
Yep. So Cameron, you okay with that?
Yeah.
Okay, that's part A. All right, let's have a think about how part B would look. Okay? And then I want you guys to give that a go. And once you give that a go, if anyone's game, you guys can show me your answer on your webcam. All right, but let's have a look at this one. You got, let's use blue so we can kind of keep them separated. Okay, so you got y equals to 3 log 2 x minus 1. Okay, let's invert that into exponential form. Someone want to do that for me? I mean, hold on. I've completely, no, I haven't, not completely, but I have buggered it up. Okay, so that's x there, and then that's minus 1. Okay, cool. What would I do before I put that in index form?
Rearrange it.
Yeah, rearrange it. Help me out, Artie.
We would do 3 log 2 of x equals y plus 1.
Okay, so bring the minus 1 over to the other side. So
Yeah.
y plus 1
And then divide both sides by 3.
equals to 3 log e to the x. Yep.
Log
Divide
2.
both sides by 3. So y plus 1 over 3 equals to log e to the x. Is that right?
It's log 2 to the x.
Of course it is. Let me just change that. Hang on. Log 2 to the x. Good. Okay, keep going. Hang on.
And then
I'm just gonna plug this into my battery. So plug some power into my laptop as I'm going. Yep.
so from here it would be x equals 2 to the power of all that on the left.
Yes. So it'd be x equals 2 to the power of
Y plus 1 all over 3.
y plus 1 all over 3. Okay. And then we've got to figure out what that all looks like. Got it?
Mm-hmm.
Yeah. And in fact, the inverse function would be what?
Y equals 2 to the power of x plus 1 all over 3.
Y equals to 2 to the x plus 1 over 3. So we've got to try and graph this, yeah?
Yep.
That's what we're going to try and graph. Right, so we're going to build our way towards it. Okay? So Cameron, so this is your question, Cameron?
Yeah.
So let's build our way towards it, right? So we can start by graphing y equals to, what is it? 2 to the x. Got it? That would look like this, yeah?
Yeah.
Okay. What would y equals to 2 to the x plus 1 look like?
It'd be the same, moved 1 unit to the left.
Yes, 1 unit to the left, right? So, it would kind of look like this. Does that make sense? So that would be 1 unit. Yep.
Yep.
That's going to be, say, 2. Okay, because that's going to be, what's that? That's going to be the point 1, 2. So when we move that 1 unit to the left, that's going to be 1, 0, 2. Does that make sense?
Yeah.
Jackson, does that make sense?
Yeah, that's all good. That's fine.
Yeah. Artie, all good?
Yeah.
And what would this do to the graph? So y equals to 2 to the x plus 1 on 3. What would that do to the graph?
Change the gradient.
Yeah. So we don't call it a gradient for curves. We call
Okay.
it dilation. Yeah, it'll flatten the curve, right?
Yeah.
And that's literally what it does. It flattens the curve. Yeah. And the COVID virus curve is actually one of these curves as well. Okay. It's an exponential curve. So what it will do is, hang on, let's use blue. So in other words, instead of being here, it'll be 1, 2, 3 units across. And instead of being 0, 2, it'd be 2, 2. Does that make sense? Because instead of this being 1 unit, it'll be 1, 2, 3 units, which will end up at 2. Got it?
Yep.
Yeah. So essentially your curve will look a lot flatter. Okay?
Mm.
Yep. Everyone okay with that?
Yep.
Yeah.
Yep.
Cool. But that is not your curve. That is the inverse function of your curve, right? So your actual curve will do what? It'll be,
It'll be mirrored
image about the,
y equals x.
yeah. So it's probably going to look something more like that. Got it?
Mhm.
Yep.
Does that make sense?
Yeah.
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 Do you see the process that we went through to do this question?
Yep.
Cameron, you're okay with that?
Yeah.
So you start with a base graph, and then you add all the different bits that are going to, you add all the different bits that are actually going to vary it.
Okay.
Yeah. Cool. Now, see how you guys understood that? Okay.
Mm-hmm.
At what point have you mastered it? You haven't mastered it yet. You've basically understood it, right? Until you're able to replicate it, you haven't. And until you're able to do those sort of questions quite comfortably, then you haven't actually, you've understood it, but you haven't mastered it. Okay? And the expectation in the exam is you've got to master this stuff.
That makes sense, yeah.
Yeah. Cool. All right. So just keep going through reviewing the practice set 4. Keep going.